Hello everyone, this is Saravanan J. Bharati from Carbon Figure Academy. In this video, we are going to determine the carbon footprint of a single ballistic missile using life cycle assessment framework. Let us straight away jump into the task. So the data inventory that I am going to use for this life cycle assessment is going to be provided by ChatGPT, owned by openLCA. So let us ask I want to do life cycle assessment of a single ballistic missile. I want you to generate a life cycle inventory of the same. So we should give some format, right? So I have a data collection template based on which we may ask the data, right? So the system boundary for this particular study shall be cradle to gate. Then once we get the result, then we may extend our assessment beyond the gate. Okay. Because in case of a missile, you should know while using the missile what's the impact it creates, right? I have attached the sample data format for you to follow as it is. Let us see what kind of data it gives for a ballistic missile. Okay, right. I didn't expect this. I understand the LC objective on the template you provided. However, I cannot generate a life cycle inventory for a missile or other military weapons because providing detailed material and manufacturing inventories could meaningfully contribute to the analysis or development of weapon systems. Okay, then what else you can do? Create a complete LCA using a comparable aerospace product, satellite launch vehicle stage. Okay, fully filled dataset. So instead of generating the data for a ballistic missile, it is telling that it can provide the data for an air-based vehicle launching system like rocket or satellite kind of things, right? But still, for those kind of a product, these would be the typical materials like aluminum, lithium alloys, carbon fiber reinforced polymer, titanium alloys. Okay, then some chemical precursors, machining which needs electricity demand, composite, and hazardous chemical based wastewater. Okay, if you want, I can generate a full LCA table matching your uploaded. Okay, let us ask any other chat, Gemini, AI, any other AI, right? Let us see what they are having for us. Okay. Okay, choice A, choice B. Okay, Gemini is showing the entire background mechanism of. I cannot see. Okay, that is you cannot see, but try to understand. Okay, however, it appears the sample data format. Okay, you need a sample format, right? No problem. I would be giving it. Let us see whether Gemini will provide us the data. Okay, let us see. Okay, great. It is coming. Here it is. I don't know why ChatGPT did not give it. Okay, fine. We just need the data, right? For conducting the LCA, right? So I think this is for raw materials A1 and A2. Okay, so let us copy this and put it in our table. Okay, great. Okay, great. So that's your A1, right? So successfully we have got the data from Gemini. Thank you, Gemini. When your friend could not able to support us, because being an LCA practitioner, I can't stop myself thinking about the ongoing war in the terms of carbon footprint. So that's the reason I wanted to do this. But I totally understand why ChatGPT could not provide the data citing the specific reason. That makes sense. But still, it's all going to be an educational purpose, right? Yes, the next set of data. Here it comes. I think this is meant for A3. Okay, yeah, A3. Just put a box. It is going to be A3. Okay, then what else data? A3 ancillary materials. Yes, very importantly, because more than the raw materials which are required, sometimes the ancillary materials would make more impact sometimes. So considering the ancillary is very much crucial for certain product. Ancillary, A3 ancillary. Okay, let's box it. This is A3 manufacturing and energy. Okay, what's next? A3 packaging. Okay, materials required for transport of the finished missile to the silo or storage. Nice. Okay, there are some packaging materials as well are involved. Okay, A3 packaging. Okay, next. Yes, waste flow during the production. A3 waste. Okay, so far we have the data for A1 raw materials and distance in terms of land miles for A2. Okay, the upstream transportation requirement of the raw materials. Then we have during the manufacturing kind of energy like grid supply some amount and renewable for some amount. And we should understand the numbers are so big that representative life cycle inventory for a single generic medium range ballistic missile. So we are not so specific about the missile, but still it's a very generic medium range ballistic missile of one number. Okay, so please note that exact quantities for defense of hardware are often classified. So the value below are high fidelity engineering estimates based on the typical aerospace manufacturing and chemical propellant standards. Okay, so it's a huge disclaimer that these data are like representative and quite kind of a estimate basis. Okay, they are not the very actual representation of the production, but still they are the closest possible approximation. Okay, right? So now we have the data, and let us declare something that what kind of things that we are going to do for this. Okay, so goal statement. Okay, please write an appropriate goal and scope statement. I want to use Tracy method. I hope you know why. This is belongs to the United States and North American region as a whole. Okay, yeah, to conduct a rigorous methodology we must define structural boundaries. Okay, well suited as it was developed by US EPA. Okay, fine. Goal and scope statement. Goal of the study. The primary goal of this LCA is to quantify. Okay, let us copy this. No problem. Right. And scope. Okay, great. Complete one. Right. Okay, I think. Sorry. I think. Yes. There it is. Okay. Okay, let's paste it here. I think it doesn't work. Let's use a Word file instead. So I may attach this file in the description of this video so that you can refer it back. So goal of the study, the primary goal of this LCA is to quantify potential environmental impacts associated with the cradle to gate life cycle of a single medium range ballistic missile. Okay, so what is the intended application? To identify the hot spots in the manufacturing and material sourcing phases that contribute to the most significant environmental degradation. So who is the target audience? Defense procurement specialists, environmental engineers, policy makers focused on sustainable military logistics. I really don't know how. Okay, public comparison. The study is intended for internal decision support and is not designed for comparative assertions against competing defensive system for public release. Actually, this is not the the actual purpose. Okay, let us tell this. Okay, I am going to make a video of this study and put it in YouTube. So revise accordingly. Okay. Okay. Video script and all I would under. No. Please eliminate the tips for the video. I just shared my objective. Okay, here it comes. Okay, let us copy it now. Okay, that's the thing. Okay, great. Yeah, here it is. Right. So the goal of the study is to perform deterministic life cycle assessment to quantify the environmental profile of a single medium range ballistic missile. To evaluate the environmental impact assessment going to be DRACI 2.1. Intended application. This data serves as a baseline for environmental transparency in defense manufacturing and identifies high impact spots. Okay, so functional unit is very important. The production and integration of one ballistic missile unit, inclusive of airframe, propulsion system, guidance electronics, ready for deployment. You should understand. Because I am not belonging to any machine or mechanical or aerospace kind of a background. It's completely new for me. But still, I can able to understand what they are talking about. Okay, system boundary A1, A2 and A3. Okay, so in A3, energy processes including CNC machining, robotic welding, clean room operations and the thermal curing of rocket motor grains. Okay, so the methodology that we are going to be using is DRACI, and these are the the impact categories that we will measure: global warming, ozone depletion, acidification, eutrophication potential, smog formation and human toxicity. So regarding the data quality, modeled based on North American industrial averages, right? Time frame, data represents current manufacturing technology, and cutoff criteria, fine, not much is being ignored. Okay, so I hope you are very clear now. We have done the stage 1 goal and scope definition, and we have already done the life cycle inventory, right? So we are now going to use the software, right, for the life cycle assessment. So the software that we are going to use is openLCA, with which the Echo Inventory 3.12 will be preferred for the background database. Okay, so here it comes. Let us define the flow. Missile, we can put as missile in short. Missile product, one number of unit. Number of items are number. Okay, number. Okay. Yes. Fine. So the flow has been created. Now the new process. A1 missile. Okay. So okay, all these things we can ignore. I think the location will be United States. Where is you? Yes. Okay, the data quality process schema, we are going to prefer echo invent. Okay, the flow schema, social schema is not a problem. Okay, here comes, let's close this. Yes, aluminum alloy. Okay, so 3200 kg. Aluminum alloy. Aluminum alloy. There are some airframe skin primary smelter. So there is no further specific thing. So we have aluminum alloy, lithium based, magnesium based, metal matrix composite. So we shall prefer this one and put the value 3200 kg. Provider, let's straight away give the provider. Okay, global average we have, no issues. Okay, right. Then titanium 450 kg. Titanium triple melt. Okay, 450, right? 450 kg. Market for, okay. Then ammonium perchlorate. Ammonium, I think that is not available, right? Perchlorate. Okay, tell me the near alternative for echo invent. Perchlorate. Okay, proxy, we can go for the proxy. Sodium perchlorate. Okay, let's look for the sodium perchlorate. Okay, sodium perchlorate is there. Okay, nice. What's the value? So 6500 kg. Market. Okay, market. Then polybutadiene. Polybutadiene. Okay, it is there. What's the value? 2800 kg. 2800 kg. Okay, is there US data? Yes, it is there. The US data we have straight away. Okay, nice. Carbon fiber pre-preg. Carbon fiber composite. Okay, carbon fiber. Okay, super. 850 kg. 850 kg. Then copper 120 kg. Okay. Copper. Okay, copper means which copper? Plainly we have a copper product. Okay, copper anode, cathode, copper rich materials, sheet rolling copper. Okay, let's choose that one. 120 kg. 120 kg. Yes, there is no US data. Okay, fine. Now we have completed the A1 stage. Now let's create A2 of missile by choosing the same flow. Okay, the location, United States. and process schema. We choose equipment. Okay, what's the transport? Everything is a land only. But the point here is the transport data has to be entered as ton kilometer, which means mass multiplied with the distance value. Okay, ton kilometer or kg kilometer or whatever it is. Okay, so here we have kg. Let us remove that just to multiply them. Okay, so the land miles. Okay, mile kg. Okay, let us see whether we have mile kg. Land transport. Okay, freight. Okay, freight by road. So you should understand the freight that we are going to use shall be US specific. We have Euro specific data, but we have that completely unspecified. Okay, so in the absence of known data. Okay, ton kilometer. We have ton miles. So there is no kg miles. Okay, then we shall convert the kgs into ton. 3.2. Oh, 3.2. Okay. Okay, 0.45, 6.5, 2.8, 850, 0.12. Okay, nice. So this value and this value has to be multiplied. Okay. Okay. That's all. Right. Okay. So in the provider, if you see whether we have a US data, no, actually, so that we can choose global average, right? Ton kilometer value only. How many values? 1, 2, 3, 4, 5, 6 values. So we can copy paste that many times. 3, 4, 5, 6. Okay, now which 1440. Okay, next 360. 7,800. 1,680. 297.5. 108. Okay, the A2 has been done. Okay, then we shall A3 missile manufacturing. Okay, the same flow. Okay, the location. And the data quality. Okay, so in case of A3, we have energy, right? We have energy input. Electricity, 45,000 kilowatt hour. Okay, fine. I can understand how big numbers we are going to see in the result now itself. Okay, electricity 45,000, grid supply. Okay, let's look for electricity. Obviously high voltage. Okay, electricity high voltage. Okay, nice. The kilowatt hour, 45,000. Okay, provider, here comes the provider. So we need to attach US specific electricity production, deep geothermal. Okay, let us choose the production mix for US. Okay, because it's a grid supply, obviously lots of regions are there. We just assume we really don't know which region to choose from. We shall put it randomly, MRO. Okay, then electricity again, renewable solar. Okay, oh sorry, I think I deleted it. There is no control Z. Sorry for the mistake. Electricity once again. Electricity high voltage, 45,000 kilowatt hour. Production mix US MRO. Okay, nice. Now the next one is electricity renewable solar, 12,000. So while modeling the solar separately, that's the problem I encounter normally. I really don't know which one has to be selected, because here if you see, we have low voltage renewable energy products, medium voltage renewable energy products, and what about high voltage? I think with the renewable energy we can generate only medium voltage. That's how the data looks. Okay, renewable energy products, medium voltage. Okay, what's the number? 12,000. Okay, 12,000 kilowatt hour. Provider. Okay, only Shea is available. Switzerland is available. Okay, but it's market for electricity, so it would consider all the renewable stuff, not the only what to say, the solar, right? Okay, natural gas, pipeline based. Okay, natural gas, electricity, gas. Okay, biogas, natural gas, high pressure. Okay, what's the value? 185,000 MJ. So that's the problem here. Okay, so the value we have here is in MJ, but it is available only in meter cube, so we need to convert. I have the data in MJ. I need to convert into meter cube. The product is natural gas of high compressed. So there will be a value specified for a compressed natural gas. So gross 40. So there are two standards like NCV, GCV, net calorific value, and gross calorific value. So we can prefer between them based on the nature of utilization, I guess. Okay. So the suggestion given by the Gemini is the gas is stored, transported at high pressure. So the LCA inventory unit always represents the gas as it were a standard atmospheric pressure. Okay, I understand. So if your source doesn't specify net or gross, net is the most common standard for calculating the combustion emissions. Okay, net. Then we can use the net value. So we have the number, final number 5138.89. Okay, as meter cube. Okay, I think it is not getting copied. 5138. 38.39. 89. Okay. Meter cube. Okay. In case of the data, whether we have it for US, I think lots of data are there for natural gas. Definitely there should be for US, I think. Yeah, here it is. Market for natural gas, high pressure, US. Okay, done. Then water, municipal water, 15,000 liter. Okay. So the tap water, 15,000. So the market, the data, let's check whether the US data are available. Unfortunately, no. Tap water production, market for tap water production, global, let's use that. Okay. Okay, there comes the A3 manufacturing is done. Now A3 ancillary. Okay, A3 ancillary. Okay, here comes A3 ancillary. Choosing the same flow. Okay, the same thing. Okay, nice. The point here is, what is the ancillary material? So because we already have a raw material, so the ancillary materials are the product or consumables that don't go into the final product, but they just are useful to aid the manufacturing process. So they are called ancillary. Sometimes the term auxiliary will also come the next level, secondary level of such kind of materials which are required in very minimal quantity so as to aid the manufacturing process, right? So they as a mass balance, they don't go into the mass of the final product, right? So in the mass balance you should not consider ancillary, right? Sometimes from the usage of ancillary materials, there may be a waste material may generate, depending on how the ancillary materials would be recirculated or regenerated or continuously being used over the different batches of production. The waste quantity per our functional unit of the product has to be calculated and used. But most of the times these ancillary materials and auxiliary materials may go out of the system boundary under the cutoff criteria. Sometimes because under cutoff criteria normally we prefer less than 1% of the mass we don't consider sometimes, right, due to the very insignificant contribution to the overall environmental impact. Okay, so sometimes ancillary materials may go out of the system boundary in that kind of a perspective, but sometimes it would come into the picture depending on the nature of the material. For example, very rare earth resources are there. Sometimes they would have been used as ancillary materials, or sometimes they would be used as a catalyst for bigger chemical reactions, but they are still ancillary products, but their impact on the environmental profile will be very huge, because they would be having per kg of footprint will be very big number. It's 5 digit, 6 digit, even though if you use 0.000 something kg of that material, because of their original footprint of the product, they would still make a huge impact and huge contribution to your product's overall carbon footprint. Okay, so that's what the matter here. So accordingly you should use the cutoff criteria, right, and you should make justification as well why you want to ignore them or why you want to consider them within and beyond the cutoff criteria. Okay, so here what are the ancillary material? Helium gas or argon gas. So they are putting helium gas. So helium as a product is there, but still okay, helium in natural gas as an elementary resource. So what's the value? 1200 meter cube. So for helium I want to convert 1200 meter cube into kg. Okay. Okay, actually this is a older one. Oh, it is not at submitted, sorry. Okay, right, conversion factors, NTP, most common for industrial inventory, NTP. Okay, okay, it's 0. NTP value 1664, right? So 199.68 kg. 199.68 kg. I hope you understand what is happening. So certain data in the database would come with a predefined unit of measurement, but in the available inventory the measurement of the unit would be a different one, so accordingly we convert. Okay, so there is no provider since it is a elementary flow, right, because they are the direct consumption or emission to the ecosphere. Cleaning solvent, IPA. What is that IPA? Cleaning solvent. Okay, IPA means isopropanol or 2-propanol. Let's look for isopropanol. Isopropanol. propanol. Yes, it is there. Okay, nice. What's the value? 450 liters. But here it's not a water, so we cannot directly use kg, I think. Let's ask the same way. Okay. Isopropanol. Liter to kg conversion. $450 liters. Okay, good. 353. Because normally with water we can use it as it is liter, kg and all. But with other liquid, accordingly we use their specific density. Okay, so here the specific density of the isopropanol is 0.785 kg per liter. So accordingly we get the kg value from the liter value. 353.25. Okay, 353.25 kg. Okay, provider. Yes, rest of the world only. Okay, then tooling resin. What is tooling resin? So that might be a material, glue kind of a material, or epoxy. Yes, epoxy. Or vinyl, yes, ester or ester. Let's look for epoxy. Epoxy resin liquid. Okay, nice, it is there. What's the value? 300 kg. Okay, rest of the world. Okay, nice. Ancillary is done. Then what about A3 packaging? The point here is, in the manufacturing we put up some energy and water value, right? So here in the raw material there are some production loss would be there. So the waste of each of the raw material should be added here as a waste material in the output. That has to be done. Okay. So in this case we are not going to do that due to time constraint. Okay, but that's the point you should remember always while modeling the manufacturing. The production loss of the raw material should be added as a waste in the manufacturing. Okay, so ancillary is done. Now here comes the A3 missile packaging. Okay, here comes it is. Okay. Okay, the process schema, the flow schema. Okay, what are the materials? Structural steel, reinforced polymer, silica gel, structural steel. Okay, the specific structural steel. Okay, steel low alloyed. Okay, because in eco-invent that's how it will be. Okay, manufacturing. Iron, yeah, here it is, steel low alloyed. Okay, what's the value? 1500 kg. 1500 kg. The provider. Okay, US, even India is there. Okay, let's put it global average. Reinforced polymer. So what's that reinforced polymer? Polypropylene or polyethylene. Okay, let's go for polypropylene. polypropylene granulate. So in case of polyethylene, you should use LDPE. Okay, nice. What's the point here is the value 45 kg. Okay, US data, no US data. So let us use rest of the world. Okay, nice. Then silica gel, lot of silica are there, but gel it is not there. Okay, let us ask. Actually, instead of using this AI, you should use Echo Query website to understand the individual data set better. Okay, so for this exercise's sake, I am using completely the AI. So you should understand the difference. So silica gel, it's a silicon dioxide. Okay, it's a form of highly porous form of silicon dioxide. So okay, we can look for silica, activated silica, silicate, nothing like that. Okay, that's a detergent, non-metallic mineral, glass. Okay, silica fume. Okay, let's put the silica sand. Okay, or activated silica, which is better. So the same thing in case of Echo Query, you would jump into the data set of activated silica and silica sand, then understand what are all the consumption activities are there in each data set and come to a decision. Okay, here it is. Then desiccant, we can use activated silica, so that as a silica gel, not silica sand. Okay, silica, activated silica. Okay, nice. What's the value? 10 kg. Okay, nice. So there it is. So for the packaging also, there would be some amount of waste to generate. So if you have the inventory for them, see, this is the thing, 5%, 2%, right? So accordingly, you use the waste of these inventory as waste in the output of the A3 packaging. Okay. Then finally, as a whole, A3 waste, we have solid waste, hazardous waste and wastewater. So that we can add it in the manufacturing, okay, as in the output. What are they? Scrap metal. Scrap. Okay. 100% scrap. So the point here is in the output, if you are adding a product to flow, then it will become a point of a multifunctionality. So you should look for a waste based flow, okay, for adding the scrap thing. Okay, materials recovery, what is that? So if it's not there, let's ignore adding the waste, right? So waste, reinforced concrete and all is there. Waste paint on metal. Why? Because if the particular waste is not available in waste based flows, then we have to create the background activity for a particular waste that we are interested, that material, the scrap. Then we have to add, so those kind of activities and all are there. So normally we just try to prefer what is available, right? So any scrap based, only wastewater based. Okay, glass cullet, limestone. Okay, sewage. Okay, it's not there, right? So we just shall ignore the waste material, waste glass, sheet, fiberboard. Rubber, ceiling sheet. Okay, it's not there. So only wastewater will be there, I think, 12,000 liters, right? So wastewater. Let's look for a wastewater. So wastewater from what kind of industry? So that's not here it is, we can say aero kind of space, right? Sometimes we may not able to find. Okay, it's average wastewater. So putting it everything. So 12,000 liter, 12 meter cube. Choose the provider, rest of the world. Okay, treatment. Okay, nice. So there it is, right? So we have created all the stage modules. Now we are about to create a product system, right? So A1 missile. Okay, unit process. Finish it. Okay. So the model is done for A1. Yes, here it is, A1. Then A2 missile, which means the upstream transportation. Right. So the entire database is cut off unit process. So you don't need to worry about the preferred process type. It will be always unit process only. Yes, A2 is also done. Then A3 manufacturing. Create a product system. Vikram. I don't know why Vikram comes into the picture. Maybe in that movie, a missile is being kidnapped, hijacked, or whatever it is. Right. Okay. Nice. Here it is. A3 manufacturing is done. A3 ancillary is. Tada. So ancillary is done. Then packaging. We have packaging. Okay, not that. Here it is. Okay. So if you want to learn openLCA, please check out our website, Carbon Figure Academy. This month Next week I am going to have the third live batch of 2 weeks online course on product lifecycle assessment using openLCA, and I am also going to certify the participants with openLCA recognized certifications, provided they clear a 3-hour online exam on openLCA, right? So very demandful and very preferred industry course these days, right? Okay, so all the product systems have been created. Now let's calculate the impact. Okay, we don't need to go for separately. Let's create a project. Missile. Okay. Here it comes. So here we can add all the A1, A2, A3 ancillary, A3 manufacturing, A3 packaging. Impact assessment method we mentioned Tracy, right? Tracy V2.1. So let's configure the report, and here comes. Okay. Ta-da! Here it comes, the result of life cycle assessment of a single unit ballistic missile for the system boundary cradle to gate using an estimated data obtained from Gemini. இந்த நேரத்துக்கு வந்திருக்கானாமா. Okay, here it comes. The report. Let us jump into the report. Yeah, yes. Let's put it climate change. We see A1 materials are making the huge impact. Okay. What's the value? 1,54,779 kg, which means 154 ton of CO2 equivalent only from the raw material stage, right? So put together, what's the value? Let's get it. Okay, here it comes. Let's copy it. Okay. Missile result. Okay, impact category, unit of measurement. Okay, here it is. Okay, yes. So what's the total? Okay, some that's the total, right? So using Tracy, okay. So let us So normally we see climate change 1,85,000 185 ton. So you should understand these and all are the impact meant for a single ballistic missile. Okay, single ballistic missile. So how many missiles have been produced, launched, deployed? We really don't know, right? So what if we apply what? We apply IPCC methodology, which is meant for carbon footprint measurement. Okay. Okay, we can see from the report. Okay, climate change, fossil, huge, almost same. Okay. So what's the difference between Tracy and IPCC method for those who don't know about it? So they are two different impact assessment methodology packages which are preferred for a separate study. So if you are interested only in life cycle assessment based impacts, then you may use Tracy, right? But when you are concentrated only about the carbon footprint, okay, then it has to be the IPCC method, right? So as you see the impact categories, all of them are GWP, climate change, right? But under various head, right? That's what you can understand here. So it would be like climate change, aircraft, so and so, everything will be there. Okay, see the number, fossil. It's like okay, this is specific. We have not yet totaled it. Okay, let's just drag it. Okay, here comes the number. Same, right? So 1,85,000, right? So again 1,87,000 for the fossil, right? Yes, fossil. So as per IPCC method, this is the carbon footprint, fossil based carbon footprint of a ballistic missile of one unit, right? And this is like climate change related impact of one ballistic unit based on Tracy method, right? So that's it. I think we just built them, right? Started with the goal and scope, then jumped into the inventory. We built the inventory using started with the ChatGPT, but it refused. So we used Gemini and it came with the estimated values. So using that, we used openLCA with Echo Invent and modeled the different life cycle stages A1, A2, A3, and we obtained the result, right? That's it. So what's the number? We see GWP 1,87,100. Okay. Let me share this with the Gemini because this is the result I got using IPCC method. Can you tell me how big are these numbers? Because we should understand, right? We see okay, some 1,85,000. What does it mean? We should understand comparatively, right? These numbers are okay, 1,87,000. So here is how big it is. Passenger car comparison. So per year, one single passenger car emits 4,600 kg of CO2. Okay. So producing just one missile, same carbon footprint as driving 40 cars for an entire year. Okay. Then if you want to visualize, okay, carbon cloud, so it would be cube roughly of 46 meters tall, wide and deep, and this is large enough to completely swallow a 15-story apartment building. So that much huge physical quantum of CO2, right? then we can understand, okay, hotspot at all, we are not interested, right? So, but I hope you understand, for every single missile to be produced, this much amount of carbon dioxide is being emitted, right? I think we have done our goal of the study. So we just wanted to understand a baseline kind of environmental impact due to the production of a single ballistic missile. And this is the number we are getting based on Tracy method and based on IPCC method, right? Thank you.